Okay, so we have a spherical iron ball covered with a uniform amount of layer of ice, and it's beginning to melt at a rate of 8 milliliters per minute. Okay, now this is going to be a little bit more tricky than the other spherical problems that we've done. So, but we understand that milliliters is a measurement of volume. So that 8 milliliters per minute is a dV/dt. Let me write that down. That dV/dt, the rate of change in the volume is negative 8 milliliters per minute. Okay, that also means that we know that we're going to have the equation of volume is equal to 4/3 pi. Why do I know that we're going to have a volume equation in this problem? Because the only way to get a dV/dt is to take the derivative of that. Okay. Let's go ahead and take the derivative of that. We've done it. It's going to be 4 pi r squared dr dt. Now, the funny thing is that the question that they ask is, how is the surface area changing? I don't see any surface area in here. So let's go over here. Let's write the surface area equation, which is 4 pi r squared. And let's take its derivative of both sides. Yes?
Like, if you solve this, you would get dr dt, which you're going to need over in
Right. So if I take the derivative of this, I end up getting a dA dt is equal to 8 pi r dr dt. So what we're going to do is we're going to start over here. We're going to find out the value of dr dt, and then we can place it back over to here to find dA dt. That's exactly what we're going to. We got one other thing that we have to problem that we have to deal with now, and that is having to do with milliliters. Yeah, we really need to convert this into something that's like a unit of length cubed. So, does anyone know the conversion? Yes, Charlie.
1 milliliter of water is 1 cubic centimeter of water.
That is correct. Charlie to the rescue.
Yeah, I'm like,
Okay, again, if you don't know, in the metric system, there's a conversion of length and volume and mass.
Equals 1 gram.
You're right. If you happen to have water, 1 cubic centimeter of water at maximum density is equal to 1 gram. That also, by the way, 1,000 cubic centimeters of water at maximum density is 1 kilogram and is equal to 1 liter.
see, this makes so much sense.
Okay, so how much does a liter weigh? A kilo. So they have a conversion in this. And you can go back to length as well. But that's indeed what we needed. We need to convert that to cubic centimeters. Okay, let's plug and chug. I got negative 8. I got 4 pi. What value of r are we talking about here? 10. So 10 squared. And the only unknown now is dr dt. So it looks like dr dt is going to be negative 8 over 400 pi, which is negative 8 goes into 400, what, 50 times? Negative 1 over 50 pi. Would you please check my math there? We're good? Units?
That's a 5?
So,
What's that?
There's a 5 one.
That was supposed to be a 5, yeah. You know what's terrible? My son is a third grader. I am always hassling him about how his numbers look. And I realize I'm just as bad. All his 5s looks like S's. He does 4s without lifting up his pencil. He's like, or anyway, let's finish this off. This rate of DRDT is in centimeters per minute, and so now we're ready to go and plug and chug on the dAdt side, and that's going to be 8 pi. The value of r again is 10, and then DRDT is negative 1/50th pi. What do we got? That 10 takes that down to a 5. So it looks like negative 8 pi over 5. And this is going to be in square centimeters per minute.
But if it's decreasing, it is decreasing, so it
the
actually
pies
becomes
would
a
cancel out.
Oh, the pi's cancel. There's a pi there and a pi there. So 8/5 of a centimeter squared per minute. Is that the right answer?
Yeah, but it's positive, it's really positive.
No, it's melting. So when the surface area.
Yes, but the question asks how fast it's decreasing,
Oh,
and it's decreasing, so it has a positive.
I hate that.
They do that a lot.
I hate that.
Like a lot.
I hate the English language. I really, really do.
So we should all just.
No, it's like-
How fast is it decreasing? We should all just. It should. This is decreasing.
It's like, are you going to the football game tonight? You say, yes, I am going to the football game. No, I'm not going to the football. Wait, there's a no and there's a not. Is that a double negative, and do they cancel each other out? So if I have a decreasing, then
If you're decreasing at negative rates.
I hate the English language. All right. So it is increasing at a rate of negative 8/5 cubic or squared centimeters per minute, or it is decreasing at a rate of 8/5. Whatever.
So wait, that was the right answer?
It's okay. The right answer is that dAdt is negative 8/5 squared centimeters per minute. Okay. Trevor's point is, the question is, how fast is the area decreasing? Which means it's already implied that it's negative, so we don't say the negative anymore.
Would they do
So it's decreasing at a rate of 8/5.
on the AP? Would they do some sort of?
I hope not.
like that?
I hope. I've done a lot of AP problems, and I don't remember. I don't remember they'll play games like that.